Okay, indicator 23, we're using the quadratic formula. We talked about that a little bit yesterday, just as a quick introduction. So yesterday, you guys wrote down some steps. Don't erase your steps. I don't want you to have to write them all over again. This should be pretty darn close to what you have, but there might be a little bit of a difference, and I want you to kind of tweak your notes a little bit to add. So I told you guys yesterday, set it equal to 0, list your A, B, and C, and then I think I just said simplify. So, and that's fine, just out to the side or maybe even underneath where you have all your notes. If you want to put what simplifying means, okay, because I got a little bit more descript in what I meant by simplify, that's that steps 4, 5, and 6. So if you want to just make yourself kind of a note out to the side of what I meant in your notes when I said simplify, take right now while I'm getting attendance put in to copy down what of this you don't have in your notes, okay? And I'll come around and kind of check to make sure you have all the right steps in your notes when I'm done here. So for those of you at home, you should be in your 3-ring binder, and this is indicator 23 notes, and we will be doing a note check on this, so make sure that you get this down in your binder, these steps to solving. So when I said simplify, right, what I meant by that was multiply the denominator, multiply the plus or minus, get the same number, and then you need to know that split if perfect or not. Right? What I want you to be able to do with these notes, and I know that some of you don't enjoy taking notes, but that's okay. You got to get used to it, especially heading into high school. You're going to be doing it a lot. The purpose of these notes is not just to make you write it down, right, or to put it in your notes or to be able to do a note check. It's so that when you're sitting at home and you're trying to do one of these problems and you're stuck and you don't know where to go next, you need to go to your notes and go to this step-by-step process and see where am I at, how far did I get, and what's next. And if you have this step-by-step process written down, then it should be able to kind of direct your thinking to, okay, I got this far, but this is what I need to do next, and it should help you kind of be able to do these problems. And then, not that you guys don't very often, but I mean, if you ask for help, typically together, I say, let's go to your notes. Let's look at your notes and see where are you in the process and what do you need to do next? Like, what's your next step? And we'll go through several of these together. All right, does everybody have this written down? Nope. Okay, I'll give you another minute. We're going to kind of jump around today. That's okay. I got to cover today's lesson and tomorrow's lesson to have everybody ready for e-learning. So just kind of ride with me a little bit. If you don't have all the words written down exactly like you like them, when we're done with the lesson today, I'll put this back up on the overhead so you can go back in and kind of make sure that you've got everything you want to have written down, okay? All right, so we're going to walk through a couple of these. We're going to talk about, we're going to go through this list. Each time we do the problem, we're going to go through the actual steps that you have written down. And use these steps. And then we're also going to kind of flip back and forth because I have 2 papers for you today. I have today's and tomorrow's assignment printed out for you. One of them is just simply what we did on our jump start. It's just practicing reducing the big 3, or well, not just the big 3, simplifying quadratic answers, okay? So you'll notice on our notes, we have perfect and not perfect. And you guys know from reducing radicals that you can have a perfect radical, which means everything inside is perfect and it has a pair and it comes out, and your answer doesn't have a radical left in it. The radical just goes away. So like if I said the square root of 81, it's just simply 9, right? It's perfect, the radical goes away. Then we have the non-perfect answers where some comes out, some stays under, or maybe nothing can come out and something stays under. But in the non-perfect ones, you have a radical left. So when you have a radical left, this you simplify it by the steps that we did in our jump start, and then what we're going to kind of practice on this simplifying quadratic answers. And then when they're perfect, you do it a different way. And we're going to practice both, and then we're also going to do a couple of examples of simplifying quadratic answers, okay? So just kind of ride with me. All right, so the first one I want to do is this number 1. So go ahead and copy this down in your notes. All right, so we know that step 1 is always to make sure that it is set equal to 0. This one is, right? It's already set equal to 0. That means that there's a 0 on the right-hand side. Everything on the left is already in the quadratic order, right? We have to have our highest power first, then our power of 1, which is the plain n, and then our number that does not have a power at all always goes in that C spot. And the reason that's important is because when we were doing factor sum table, we had to connect A to C, and we had to multiply that, and our sum was our center, which was always our B. So order mattered there too. It matters here just as much, but for a little bit different reason. So step 2 in our list of solving is that you always off to the side are going to list what A equals, and here A equals 5, B equals, now what does B equal here? There's not a number there, but there is one. It's a 1, right? There's always a 1 in front of a variable. So our B equals 1, and here our C equals -6. Signs really matter, so make sure you bring your signs with your A, B, and C. And notice that A does not equal 5n squared. If the n squared doesn't come along with it, this is just the numbers, okay? So now it says plug the value into the formula. You should have the formula in your notes. I'm sure you do, but if you don't, there it is. Oh, no, that's on my other screen. It is, thing's chunky, but that's all right. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. I would like to know what was running through the head of the person that figured this out. Like, how in the world they figured out this formula is totally beyond me. All right, so what we're going to do is we are actually in the formula, right? We have, now remember, the -b, the negative is part of the formula. So we're going to think about just where the b is parentheses, just where the b is, just where the a is, the c and the a. We're going to plug all of the values into the quadratic formula for a, b, and c. So that looks like x equals negative is part of the formula. Then we're going to plug our b, which is a 1, plus or minus, because that's part of the formula, and then the square root of b squared, which is 1 squared, okay, minus 4 times our a value, which is 5, our c value, which is -6, all over 2 times a, which is 5, okay? Now, this is where I got a little bit more specific in my notes, and you can do step 4 and 5 together, okay? Save yourself some paper and some writing and some time. Do steps 4 and 5 at the same time. So we're just going to simplify this. I mean, we're going to clean it up as much as we can. So the -1 just stays -1, plus or minus. Now, underneath this radical, you can do this in one step or two. I'm going to show it to you in 2 steps. Once you get a little bit more comfortable with this and you want to do all of this in one step, you can. But for right now, I'm going to square my 1, which is just simply a 1. And then I'm going to take -4 times 5 times -6, okay? So you've got -4 times 5 times -6 is positive, this is where signs really come into play, positive 121 all over, and then it also says multiply your denominator. That's that step 4 and step 5, okay? We're working toward that. Now, we're not quite there yet because we need to simplify underneath that radical, and you'll notice in your notes it says get to a single number under the radical. So I'm going to keep working until I have, yeah. Oh, I'm sorry, I already added the 1. Thank you. It says 120 on my calculator. Sorry, it's 120. I was already adding them together. I was doing that all in one step. Thank you. All right, so x equals -1 plus or minus. Now, this is where if you didn't do it in the one step, okay, don't do it in the one step like I did. 1 plus 120 is 121 all over 10. Now, I am to the point now where I have to split my thinking into, is 121 going to be perfect or not perfect? Because that's going to change how I do the problem, okay? This is where you kind of split, fork in the road. You're going to go one way or another, okay? You can't go both. So I'm going to come out to the side, and I'm going to either do it on paper or I'm going to punch the square root of 121, which I would recommend doing it this way first. The square root of 121, if you put it in your calculator and you hit equals, you get 11. You get a nice whole number, which means 121 is perfect. Okay, you don't get a decimal. That means that 121 is actually 11 times 11. It's a perfect square. So that means the 11, right, the square root of 121 comes out as 11. It's perfect. The radical's gone. So that means that I am going to now rewrite this with -1 plus or minus 11, because 121 is perfect and came out exactly as 11 over 10. Now we know that when we solve quadratics, we always get 2 answers, and here's how we get the 2 answers. At this point, because it's perfect, you split and you work it twice. So you're going to have x equals -1 plus 11 over 10, and then you're going to have x equals -1 minus 11 over 10. And now you are going to work this as 2 separate for our equations, and you're going to get 2 separate answers, and then you're going to write your final answer in the braces showing your 2 values for x. So on the top, -1 plus 11 is 10 over 10. It looks like 16, but it's not. 10 over 10 equals 1. So when we do it with a plus 11, we get a 1. When we do it with a minus 11, we get -1 minus 11, which is -12 over 10, which reduces, always reduce your fractions, but leave them as fractions, reduces to -6 over 5. So our answer for what x can equal, there's 2, is -6 over 5 and 1. So this goes right back to the last indicator where when you have a quadratic and you solve it, we solved it by factoring last indicator. This indicator, we're solving it by the quadratic formula. Both are valid ways. It's just not always usable on both. Well, let me say that different. You can always use the quadratic formula. You can't always use factoring, okay? But you still write your answer as the 2. Now, I want to look at this one. The one I tried to give you yesterday was a terrible example. And this one is too, because you could actually solve this one by factoring. So it's always easier to solve it by factoring if you can. But if you can't, then the quadratic formula is kind of the dependable, right? Nothing flashy about it, nothing quick. It's always dependable. You can always use it. Solving by factoring is great when you can use it because I think it's easier, but it doesn't always work. And I'll show you this as a good example. Okay, don't put this down in your notes. If I first get it set equal, well, go ahead and write this problem down in your notes because the first step we're going to do the same. Go ahead and write example number 2 in your notes because we are going to still work it together. And of course, the first step is always to make sure that it's set equal to 0. This one is not, so we are going to make it set equal to 0 by adding 2 and adding 2. And I already have a whole number on the left, so I'm just going to combine my -1 with my +2. So I get as my quadratic 6n squared plus 9n plus 1, my equal sign's off, isn't it? Equals 0. Now my quadratic is set equals 0. Now, don't write this part down. I just want you to see what I'm talking about because the two examples I've tried to show you, they've not been good examples. If I try to do the factor sum table, right, and I do my 6 times my 1 is 6, and then they add up to 9, there are no winning factors. They don't exist because 1 times 6 only adds up to 7. You cannot add up to 9 with any factors of 6. So this is a good example of factoring will not always work. Quadratic formula will always work. So if you're not told how to solve it, then try factoring first because it's easier. But if that doesn't work, you can go to the quadratic formula. But in most of these tests and quizzes, you're going to be told solve by factoring, solve by quadratic formula, that kind of thing. All right, so back to the quadratic formula. That was just kind of a side note of why we have different ways to solve these, okay? List our A, B, and C. So our A is 6. Our B equals 9, and our C equals 1, okay? And so now we're going to plug into our formula. So it's x equals negative b, which is -9, plus or minus the square root of. Now, I'm going to do it this way this time. I've done it the long way once. Now I'm going to start showing you how to incorporate a few shortcuts. You can write 9 squared here, or you can save yourself one step and you can write 81. I'm fine with those skipping little steps like that. Minus 4 times A times C, all over 2 times A, okay? Now we just keep simplifying. This is a multiple step process, but you just have to go through the process. -9 plus or minus the square root of 81, and then -4 times 6 times 1 is -24, all over 12. And then, and if you want to do this 81 minus 24 in that same step, saves you a little bit of writing. As long as you're comfortable with it, that's fine. 81 minus 24 is 57. Okay, all over 12. All right, now I'm to the point where I need to decide if 57 is perfect or not. Hopefully you're familiar enough with your perfect squares. If you put the square root of 57 in your calculator, you actually get 7.5498344, blah, 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 blah. It's not perfect, okay? So we need to decide, is it factorable? So you come out to the side, and it's not divisible by 2 because it's not even. 5 plus 7 equals what? 12? So that tells us that it is divisible by 3. So you take 57 divided by 3 and you get 19. What's special about 19? It's prime. Do I have pairs to circle? No. So can the square root of 57 be simplified? That's as simplified as it gets, which means, okay, I don't have a big 3, right? Because this is a 1. 1 is as simplified as it can get. So since I don't have a big 3, I'm done. That's my final answer. I tried to simplify 57. It didn't work. Since I couldn't simplify the 57, that just stays my answer. Okay? Any questions on that one? Okay. I made sure I picked 3 examples that all gave us a little something different that should cover everything you'll see on your homework, especially since we won't be here tomorrow in person. All right, so first thing is get it set equal to 0. So I'm going to add an x. When I combine that on the other side, I have another x over there. So I'm going to write that add x right underneath that other x because I'm going to combine like terms when I move stuff around. I'm also going to subtract 24. And I don't have another whole number over there, so I'm just going to stick it over there for right now so I don't forget it. But it's got to go in the right order, okay? So when you do that, look and see what you have on the left. First, you have a 4x squared that didn't have anything combined with it, so it just stays 4x squared. For my x's, I had -9, I added 1, so now I have -8x. And for my whole numbers, just that -24 that I pulled over equals 0. Now I'm ready to actually write my A. My A equals 4, my B equals -8, and my C equals -24. Okay, so let's go to our equation. X equals, now I want you to pay very special mind to this. The formula says minus B. My B is already a -8. What is minus a minus? It goes plus. You can do it in one step or not. I'm going to go ahead and write it out this first time. So the formula says negative B, and my B is -8. So negative B, or -8, plus or minus B squared, which in this case, B is -8. Now, when you square a negative, what does it do? This is the most common mistake. When you square -8, is it -64? Be mindful. When you square, this term right here will never, ever, ever be negative. It can't. This first term, because when you square B, it's going to go positive whether B is negative or positive, okay? So B squared, or 8 squared is, -8 squared is 64, minus 4 times -24. Okay, your signs really matter here. All over 2 times 4. So let's clean this up a little bit. -8 is positive. If you did that in one step earlier in the process, totally fine. Plus or minus 64, and then I've got -4 times -24. That tells me it's going to be a positive, and then, of course, times the 4. So I've got 4 times 24. Incorporating all your negatives, you get plus 384. All over 2 times 4, which we reduce to 8. Okay? Whoops. There we go. Now we're going to clean it, keep going with the reducing. We're going to simplify underneath the radicals. So we've got 8 plus or minus 64 plus 384 is 448. Now, I want to stop right now, and I want you to put this in your notes. Okay? I want you to put a big arrow right here. Okay? Can never be negative. If when you get to this point and underneath your radical is negative, you've done something wrong. Go back and look at your signs. Okay? You've either put a negative when you squared the B, or when you multiplied your -4 times your A times your C, or somewhere along the line you've messed up a sign. Okay? All right, so now we're going to make our life easy because I don't want to do all the math if I don't have to. And I'm going to punch in my calculator the square root of 448 equals, and I don't get a perfect number, okay? I don't get a whole number. So that tells me that I need to come out here to the side, and I'm going to do the square root of 448, and I've got to factor it. So 2 and 224. 2 and 112, 2 and, what is that, 56. Remember to stick with 2 as long as you can so that all your 2's stay together. 2 and 28, if I ever make a mental error, please holler at me. 2 and 14, 2 and 7. Okay, so now I'm going to circle my pairs. I circle a pair of 2's, they come out as 1. I circle another pair of 2's, they come out as 1. Another pair of 2's, they come out as 1. Can't circle the 7, stays trapped. So my reduced version of this large number is simply 8 squared. Whoops, I I put the 8. I was already thinking ahead to my answer of 8. 8 square root 7. Okay, that is 448 simplified. So now I go back to where I left off in my quadratic, and now I'm going to replace the square root of 448 with my simplified version. So x equals 8 plus or minus 8 square root 7 over 8. And if you follow your note train, when it's not perfect, your last step is to simplify the big 3. So do all my 8s, obviously, not a trick question. 8, 8, and 8, all reduced to 1. Now, in math, there are some ones you don't have to write and some ones you do have to write. And in this case, this first one has to be written because it's a placeholder, right? It's the only thing there, so you can't not write it. You do not have to write the 1 in front of the 7, and you don't have to put it all over 1 because everything is really always over 1. So the very, very cleaned up version is right here. Okay, x equals 1 plus or minus the square root of 7. Now, does this still constitute, or does this still represent 2 answers? What do you think? Is this still 2 answers? All quadratics have to have 2 answers. This is still 2 answers. The only difference is we want exact answers. I could put 1 plus the square root of 7 in my calculator, right? 1 plus the square root of 7 in my calculator, and I get 3.645 for forever and ever, okay? Then I can put 1 minus the square root of 7 in my calculator, and I get negative 1.645, blah, 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 forever and ever and ever. So this still represents 2 answers, but we don't, it's saving time, okay? Don't ever do this, okay? 1 plus the square root of 7, 1 minus the square root of 7. That's all this means. But this is just, there's no need for it. It takes up extra time. You don't need to do it. And because we want exact answers, you don't want this to be converted into a decimal and put a decimal. So that's why we leave it like this. Whoops. Pen shuts off randomly every once in a while. That's why we leave it like this. Shorthand, okay, right? I always kind of jokingly say mathematicians are lazy. So although the person that came up with this formula, probably not lazy. All right. Last one, and then I'm going to give you guys some time to practice simplifying quadratic answers, and then also doing these quadratic formulas. All right, so this one's nice and easy. It's already set equal to 0, so that makes it kind of nice. So we are going to establish our A equals 8, our B equals 4, and our C equals negative 22. I will tell you on tests and quizzes, this step right here is worth 1 of your points. So quadratics are typically worth 4 or 5 points apiece because there are so many steps. 1 point comes from listing what your A, B, and C equals. So don't take the shortcut. All right, so now let's plug it in. X equals negative B, which is negative 4, plus or minus. Now, I'm going to take a shortcut here and say that 4 squared, or B squared, is 16. So I'm going to go ahead and write out 16. Minus 4 times A times C, which is negative 22, all over 2 times A, which is 8. Okay, and we start cleaning it up underneath that radical. So negative 4 plus or minus, and then up underneath this radical, we've got 16, and then you've got negative 4 times 8 times negative 22, and you get positive, because a negative and a negative, then times a positive is positive 704, okay? All over 16. If I could give you a piece of friendly advice, do the signs on your own. Some calculators, especially if it's like a real small calculator, some calculators, and they do it in my, I keep calculators in my classroom at the high school for everybody to use. And sometimes for some reason, when you try to punch negative 4 times 8 times negative 22, Something about just the way you hit the buttons or whatever, the negative doesn't catch once or something, and you end up with the wrong answer. If you look in your head, you've got a negative times a positive times a negative. That negative and negative is going to go positive, and then times the other positive is going to stay positive. So if I were you in your calculator, I would just put 4 times 8 times 22. Don't rely on your calculator for signs, okay? It'll just help you. All right, so then we've got x equals -4 plus or minus. Now, I'm going to do this all, well, no, I'm not. Square, or 16, sorry. 16 plus, was that 704? Yeah. Equals 720 over 16. Nope, doesn't equal 720. Yeah, it does. Stick with me, guys, sorry. I'm trying to do shortcuts and not shortcuts, and I forget which shortcuts I do. All right, so we're going to take 720 in our calculator. We're going to try to see if it's perfect. It is not, okay? So we take over here, and some of your calculators might actually give you the simplified answer when you do this. I don't know. If so, take the shortcut. You already know how to do this part. So 2 times... 720 divided by 2 is 360. 360 divided by 2 is what? 180? 180 divided by 2 is 90. 90 divided by 2 is 45. I've hit a stop with my 2's. 45 is 3 and 15. Kind of running out of space here. 15 is 3 and 5. So now I'm going to circle my pairs, and I've got a pair of 2's. I'll do it over here. They come out as 1. Another pair of 2's. They come out as 1. Pair of 3's. They come out as 1. What cannot come out is that 5. And so my reduced 2 times 2 is 4 times 3 is 12, square root 5. So now I'm ready to rewrite my go back to my quadratic formula, -4 plus or minus. Now I'm going to plug this right here in for, because that's my reduced version, over 16. Okay, now your last step, because this was not perfect, your last step is always look and see, can you reduce the big 3? Is 4, 12, and 16 all reducible by the same number? They're all evenly reducible by 4. So when I reduce 4 by 4, I get 1. 12 by 4, I get 3. 16 by 4, I get 4. So your last step is to write it in a nice cleaned up version. Remember, you have to write that first -1 because it's a placeholder. And then 3 square root 5 over 4. Okay? Any questions on those? All right, I want to pass out a paper real quick. That's not it's part of your homework, but it's part of what we're going to do together. And I'm not going to walk the back, so if you guys would just shuffle left and right, make sure everybody gets one, that would help me. That would be a little bit more time efficient for me. There'll be 2 extras, just one of you set it on one of those back desks, and I'll come back and get it in a minute, okay? So we're going to just work through a couple of these together. I'm going to bounce around the page and work on some of them together and some of them on your own. I'll try to hit an example of every kind you might see. This is simply a worksheet that helps you practice. Once you get to that final step of the non-perfect ones, it helps you reducing, all right? So like I said, I'm just going to kind of jump around the paper and work a few of them together, and then the rest of them will be part of your E-Day homework. And then the paper that I have here is the rest of your E-Day homework. So in number 1, right, it's already reduced to the big 3. Is 7 simplifiable any more than it already is? 7 is prime. So you can't simplify under the radical anymore. So you just simply look at the big 3. They're all divisible by 3. So you're going to reduce 6 by 3, which is going to give you a 2. 3 by 3 is going to give you a 1. 9 by 3 is going to give you a 3. So your answer here is 2 plus or minus square root 7 over 3. Okay. Number 2, how about 49? Is 49 simplifiable? Okay, it's perfect. It's actually, if you recognize it, it's 7 times 7. So it's perfect. It comes out as a whole 7. So you've got x equals 7 plus or minus. It's perfect, which means your 7 is going to come out without a radical over 7. Okay? You now, because it was perfect, what do we do? When it's perfect, what do you do? It's in your notes. If it's perfect, and then if it's not perfect, what did you have in your notes for if it's perfect? It's 3 words. Split and solve. Thank you. If it's perfect, you split and solve. Okay? You write it as 7 plus 7 over 7, and then x equals 7 minus 7 over 7. Okay? 7 plus 7 is 14 over 7, which reduces to 2. 7 minus 7 is what? 0 over 7. What's anything with a 0 on top? 0. So your answer here is 2. Well, let's put the 0 first. 0 and 2. Okay? Perfect, you split and solve. Not perfect, you simplify and then reduce the big 3. All right, how about the 2 under the radical? Can it be reduced? Nope, so you just simplify the big 3. They're all simplifiable by 2. So we have 4, 2, and 3. So your final answer would be 4 plus or minus 2 square root 2 over 3. Okay? Let's see. How about this one right here? Number 6. 50 needs to be reduced. So we do 2 and 25, 5 and 5. So the square root of 50 simplifies to, the pair of 5s comes out as 1. The 2 stays trapped. So 6 plus or minus 5 square root 2 over 6. How about the big 3? 6, 5, and 6, can they be reduced? So that stays your answer. So your big 3 may not always be reducible, and that's okay. If it's perfect, split and solve twice. If it's not perfect, simplify and then reduce the big 3. All right, I'll give you, you can work on this. If you happen to get done with this, I have the key up here. You can check your answers. And then this is the other half of your assignment. This is all due on Thursday. I say all, it's not much. It's 2 short worksheets. And I trimmed this one, this quadratic formula one. There were 23 problems. I said, no way. I wouldn't want to sit and do 23 of these problems. So I combined it down to 8. Unless anybody wants 23. I'll be happy to do No, I'm going to be here. So let's, Thursday is going to be a review day. Everybody's going to have a review sheet to work on. So I'm going to go ahead and give you the test or the quiz on Thursday. We'll take the first half of the class and the second half of the class. Everybody got one? Oh, thank you. Everybody got one? We're good? All right. Work through these. If you have any questions, ask. If you get stuck tomorrow or you get hung up, this goes for everybody at home as well. If you get hung up on anything or you don't understand something, please shoot me an email. If it's a quick question, I always email you back with the problem worked out in steps. And if it's more in depth, we can always open up a Google meeting and I can help you one-on-one. And that goes for you guys here in class as well. If you get stuck tomorrow and it's a big stuck, we can open up a Google meeting real fast. If it's a little stuck, I can just nudge you to the next step via email. But either way, I'll help you. All right. Let me know if you need anything.